Pitot system. Objectives. After completing this section, you will get familiar with components of the pitot system and operation of the pitot system. Components of the pitot system. The pitot system is a system that supplies pressure-sensitive instruments with pitot pressure and static pressure. The Da-40NG airplane has a single pitot probe and 2 static ports. The pitot probe is mounted below the left wing to sense the pitot pressure. The static ports are flush-mounted holes on the fuselage to sense the static pressure. The pitot system consists of a pitot probe, 2 static ports, pitot static instruments, an optional alternate static valve, flexible plastic hoses, which include filters, as well as water traps, and an electric heater element for the pitot probe. The pitot probe has a single orifice that senses the total pressure, while the static pressure is sensed from 2 ports. Both pressures are supplied to the air data instruments with the help of flexible hoses. The pitot system is an essential component that is connected to Garmin G1000 cockpit system, if installed. Altimeter, airspeed indicator, vertical speed indicator, and a blind altitude encoder. The pitot system is particularly vulnerable to failures, especially when blockage of the pitot probe or static ports occurs. To prevent the pitot probe from failing, filters are used to protect the probe against dirt, insects, mud dauber, and condensation. Similarly, both static ports are also connected to filters, with the same functions as the ones used in the pitot probe. These filters are accessible from the root of the left wing. The pitot probe is equipped with an electrical heater element, used to prevent icing. The pitot heating is activated by a switch called pitot, located on the instrument panel. Moreover, a safety circuit breaker protects the pitot system, in addition to a thermal fuse built in. The pitot heating system is supplied from the essential bus. The heating temperature is adjusted automatically, and kept constant. The static pressure in the Da-40NG airplane is measured by 2 static ports, located on the rear fuselage section, 1 on each side. The ports must always be cleaned and checked regularly for any blockage. Every static port has a keep clean guidance sign. This sign recalls the negative impact of port blockage. An optional alternate static valve is installed on the left bottom side of the instrument panel and works as a backup source for static pressure in case the pitot probe fails. An optional alternate static valve is installed on the left bottom side of the instrument panel and works as a backup source for static pressure in case the pitot probe fails. Warning: if the alternate static valve is open, emergency windows and cockpit vent must be closed. Operation of the pitot system. The hoses for the pitot system are of different colors. Pitot hoses are colored in green, while static hoses are in red. The airflow passes through flexible hoses, which connect the orifices of the pitot probe and the static ports to the instruments. The pitot probe is connected to a heater system that prevents ice from accumulating on the probe. Both pressures are fed to the air data computer and integrated cockpit system via hoses. The ADC supplies the Garmin G1000 and the airspeed indicator with both pitot and static pressures, while it only supplies the altimeter with static pressure. Both pitot and static hoses have water traps, located at the lowest part of the hose run. Each hose has a T-piece junction, which divides the hose into two runs. One run goes directly to the air data instruments and the ICS, while the other forms a sump, where the water is stored, before rejoining the direct run at a T-piece. Y-shaped connectors are used to make the connections in flexible hoses. Summary. With this section, you got familiar with components of the pitot static system and operation of the pitot static system.